In 5.4, we talk about systems of nonlinear equations in two variables. So a system of two nonlinear equations in two variables is also called a nonlinear system. Contains at least one equation that cannot be expressed in the form ax plus by equals c. A solution of a nonlinear system in two variables is an ordered pair of real numbers that satisfies both equations in the system. The solution set of the system is the set of all such ordered pairs. And so how can we solve these? So we can use the substitution method, particularly when one of the equations is linear. So when one's linear, substitution is a good way to go. So for example number 1, we want to solve by the substitution method. X squared equals 2y plus 10 and 3x minus y equals 9. So let's go ahead and label our equations. Equation 1 and equation 2. Now equation 2 is linear. So we can solve for a single variable and plug it into equation number 1. So let's look at equation number 2. 3x minus y equals 9. I'm going to solve for y. So we have negative y equals negative 3x plus 9. So y equals 3x minus 9. Since it's solved for a single variable, we can plug into the other equation, which is equation 1. X squared equals 2y plus 10. So wherever we see a y, we plug in 3x minus 9. So we have x squared equals 2 times 3x minus 9 plus 10. So x squared equals 6x minus 18 plus 10. We can combine like terms. So we have x squared equals 6x minus 8. Let's go ahead and set this equal to 0. So x squared minus 6x plus 8 equals 0. Now the way to solve this is by factoring if possible. So let's look at x squared minus 6x plus 8 equals 0. So AC equals 8. We'll have either 2 pluses or 2 minuses. And since the middle term is negative, we have 2 minuses. And negative 2 and negative 4 would give me negative 6. So we end up with x minus 2 and x minus 4 equals 0. And now we want to set each piece equal to 0. X minus 2 equals 0 and x minus 4 equals 0. So we get that x equals 2 and x equals 4. So now we want to back substitute for two different x values. So plugging back into equation number 2, this is when x equals 2. We have 3 times 2 minus y equals 9. Well, that's 6 minus y equals 9. Or negative y equals 3, which means that y equals negative 3. Now let's do the same thing for x equals 4. We've got 3 times 4 minus y equals 9. Well, that's 12 minus y equals 9. Negative y equals negative 3, which means that y equals 3. So we have two different ordered pairs. We have the point 2, negative 3, and we have the point 4, 3. So go ahead and pause the video and try example number 2 on your own. Alright, so in this one, same idea. We have x minus y equals 3, and we have x minus 2 squared plus y plus 3 squared equals 4. So let's go ahead and label our equations. And equation number 1 is a linear equation. So we can go ahead and solve this one for a single variable. I'm going to solve for x. And so we get x equals y plus 3. So now that we have a single variable, we can plug into the second equation. Wherever we see x, we plug in y plus 3. So we have x minus 2 squared plus y plus 3 squared equals 4. So wherever I see x, I plug in y plus 3. We have y plus 3 minus 2 squared plus y plus 3 squared equals 4. Well, that's really y plus 1 squared plus y plus 3 squared equals 4. So we're just going to write this twice in FOIL. And so we end up with y squared plus y plus 1 plus y squared plus 3y plus 3y plus 9 equals 4. Let's go ahead and combine like terms. And so we get 2y squared plus 8y plus 10 equals 4. And let's go ahead and set this equal to 0 as well. And so that's 2y squared plus 8y plus 6 equals 0. So we can factor this. So the first thing you always start with is the GCF, which in this case is 2. So we can pull a 2 out. We're left with y squared plus 4y plus 3 equals 0. We're going to do AC, which is 3. And we got 2 pluses. And 1 plus 3 would get me 4. So we have 2 times y plus 1 times y plus 3 equals 0. And set each piece equal to 0. So y plus 1 equals 0. And y plus 3 equals 0. And so we get y equals negative 1. And y equals negative 3. So we have two values for y, and we need to find our values for x. So we can plug back into equation number 1. Now in the last example, I plugged it back into the original. In this one, I'm going to plug it back into the equation where we solve for a single variable. X equals y plus 3. So let's go ahead and use y equals -1 first. We have x equals y plus 3, or we get x equals -1 plus 3, which is 2. Let's do the same thing for the other y value. Y equals -3. We have x equals y plus 3, but that's just -3 plus 3, which is 0. So our two coordinates are 2, -1, and 0, -3. We can also use the addition method to solve these nonlinear systems. So in nonlinear systems where both variables are squared in both equations, these are best solved by the addition method. So like in example number 3, 4x squared plus y squared equals 13, and x squared plus y squared equals 10. And so we're going to want to multiply one or both equations by a non-zero number so that we can get the same number but just one positive and one negative. So let's go ahead and number our equations. And so both of my y's are squared, and they're both have a coefficient of 1. So I'm just going to multiply the second one by a -1 so that when I add them together, they cancel. So equation 1 isn't changing. And equation number 2, I'm multiplying by -1. So we get -x squared minus y squared equals -10. So let's go ahead and add this together. 4x squared plus -x squared is 3x squared. My y squared and -y squared cancel. And 13 plus -10 is 3. And so dividing both sides by 3, we get x squared equals 1. And using the square root property, we get x equals plus or minus the square root of 1, which is plus or minus 1. So this means we have x equals 1 and -1. Now we want to back substitute to find y. So I'm going to plug this into the second equation. Let's do x equals 1 first. So we get 1 squared plus y squared equals 10. Well, that's 1 plus y squared equals 10, or y squared equals 9. Again, by the square root property, we get y equals plus or minus the square root of 9, which is plus or minus 3. So this time I have two y values with a single x value. So I have the point 1, 3 and 1, -3. And we want to do the same thing for x equals -1. And so we have negative 1 squared plus y squared equals 10. But this is just 1 plus y squared equals 10. We get that y squared equals 9. Again, by the square root property, we get y equals plus or minus a square root of 9, which is plus or minus 3. And so I have two y values for a single x value, which means I have negative 1, 3, and negative 1, negative 3. And so we ended up getting 4 different points. So go ahead and pause the video and try example number 4 on your own. Alright, so let's go ahead and label our equations. This one might look like a good one for substitution. However, when I plug in, I would end up with a 4th degree equation, which we don't know how to solve yet. So I'm going to rewrite equation number 1 so that my variables are on one side. And so let's subtract x squared from both sides. And you get negative x squared plus y equals 3. Let's go ahead and add equation 2. X squared plus y squared equals 9. And so it works out nicely that x squared has a positive 1 and a negative 1. So when I add them together, they end up canceling. And so what I'm left with is y squared plus y equals 12. Now remember, we can't add y squared and y together because they don't have the same exponent. And so we're just going to solve this quadratic equation, which means let's set it equal to 0. So y squared plus y minus 12 equals 0. AC is negative 12, so we're going to have 1 positive, 1 minus, and we will have a positive 4 and a negative 3 to get that 1. So we got y plus 4 and y minus 3 equals 0. Set these both equal to 0. And we end up with y equals negative 4 and y equals 3. So just like in the other ones, we got to plug in 2 different y values. And so I'm going to plug this back into equation number 1. Y equals x squared plus 3 and we're going to plug in y equals negative 4 first. So we get negative 4 equals x squared plus 3, or we get negative 7 equals x squared. And then by the square root property, we get plus or minus the square root of negative 7 equals x. And if we have a negative underneath a root, we can go ahead and pull an I out. So we have plus or minus I square root of 7 equals x. And because it's imaginary, we won't worry about this because we can't actually plot it on our graph. So go ahead and just cross it out, and we're going to go plug in the other value. Y equals 3. So y equals x squared plus 3. Well, that's 3 equals x squared plus 3, or 0 equals x squared, And so we get that x equals 0. And so our point would be 0, 3.